I want to make a quick video to show you a little bit about the process that you want to think about as you clean up your Kraken tabular reports to only include data for phylum level classifications. I also wanted to make an updated video to show you a little bit about how to work in Posit Cloud and how to avoid some common errors that I've seen this week in office hours. So the first thing I want to show you is this wonderful icon, the broom, that allows you, before you run any new code that you've typed, to clear your environment. Some of you are running into issues where the code that you're writing is fine, but you're pulling data from old variables. And so while those old variables are there, it will work. But when the variables go away, your code no longer works. So if every single time before you run a program, you click this, you'll know that your code is working as intended. The second thing that you can do that can be really helpful is just clear your console, just like a nice way to sort of start off fresh. Many of you took biostats last semester and are familiar with the markdown file more than the script file. Both are totally acceptable for this class. I want you to work in the tool that you feel most comfortable in, but I'm going to demonstrate the markdown file for you just to get you started with it. So the first thing you do if you want to create a markdown file is do new file, markdown, give it a title, say assignment for Ben 345, say okay. And you'll see in our setup that you can include in the file. And this is a great place to use all of your library commands after you've installed the packages from tools install packages. And just have that be something that runs in the background with include equal to false. So if you were to publish this to RPub's website or some other tool, you don't have to show all of that library information. When you open up a template like this, you'll see a lot of information of an example of a markdown file. You can get rid of all of that example information, and you should get rid of it. You shouldn't be turning in scripts for this class that have that old template. Now, when you want to create a new code block, you can click Insert New Code Chunk, or you can see with the tooltip, you can press on your keyboard Control-Alt-I. So it's very convenient to be able to just hit on your keyboard and add that new code chunk. What's nice about the markdown files and using these chunks is it's a little bit faster than clicking on individual lines and hitting run. You can just run that whole group together. So that's how I've set up this script. And we'll run through it. We'll load the library. We'll load the data. And let's look at the data that we read in to make sure it read in correctly. You can see it's nice and organized, 2 even columns, no empty spots. And each of the classifications from Kraken have a count next to them. Now we're ready to start removing rows that do not match our criteria. This week, it's going to be looking for phylum. Next week, you're going to pick your own classification. So you might do this assignment again to look at genus, class, order, family, any of the other levels of taxonomy. Because the organizational level after phylum is class, removing class is the fastest way to get rid of most of the rows. So I'm going to run that chunk. It's looking for this pattern, pipe C. That's what all of the classifications will have. And anytime it finds it, it gets rid of it. I searched all of PROS1, that data frame, for that pattern using the grepl tool. We did this in the tutorials to compare words. It's basically like a word math tool, and it gives true or false. So grepl category will come back true. And I'm feeding it into a new data frame just so I can keep track of what I've filtered out, and I called it PROS1A. I actually got this idea from one of you in this class. So PROS1A is only 22 observations. We got rid of most of the rows, but not all of them are at the phylum level. So I see right away that the first row is just at a domain level, right? So not at a phylum level. And I see there's a couple of extras in here that are at the order level, and they didn't have a class assigned to that taxonomic classification. So my first filter didn't get rid of them. So now I do a second filter. And because I saw O's in the data frame, I'm going to get rid of O's. Your data may be different, right? We all have totally different data sets for this project. So I run that and it got rid of 4 rows, cleaned it up a lot. But oh, there's still some G's left in here. I got to get rid of those. So I did that with another filter, getting rid of the G, the pipe G pattern. And now I got down to 16. And now for the rest of them, I'm just going to look. There's only a couple left. It's pretty easy to count what row they are on. I can see D bacteria, so row 1 I want to get rid of. And if I scroll to the bottom, all these eukaryota, these are human contaminants. It's kind of up to you whether you get rid of all of them. You're allowed to keep the chordata, the phylum level, but I would just get rid of all of them. So I'm going to get rid of rows 1, 14, 15, 16. I can do that easily by making a little list with the C command, 1, 14 to 16. And then when I run this code chunk, I now have only 12. And when I look at it, they really are all at the phylum level. Now I'm ready to clean up the data for plotting with ggplot. I run the names command to change the column headings to phylum and count. I then run a for loop with gsub to look for this pattern, D underscore to P underscore. And when I run this, I get a cleaned up set of names, very similar to what you just did for species. And then I'll tidy the data. If I have both sets of data, I would bind them together in my data. I only have one set of data, so I'm just going to run it with my data. And then I'm going to run the taxonomic bar plot. And I can see the picture here looks great. I can open it up and look at it, and I can see, okay, I really have a clear breakdown of all the phylum that are in my sample. And it's not surprising, but firmicutes and Bacteroidetes, those are the ones that we're going to write a report on later this week or make a table later this week. Those are the highest abundance of all the phylum. So totally normal results for a microbiome project. A couple of you have run into a problem where you're using a markdown file and you're not sure how to get the plot onto your computer because it's showing up as a preview here in the HTML. There's a lot of different ways to do this, but one of the easiest is store the plot in a variable P, run the code chunk, and then just type the letter P on the console so that it opens up in plots, and it's easy to export, save as image, and download it onto your computer so that you can turn it in on campus or insert it into a Google Doc. The last thing I've seen people run into with office hours is file naming. I named this file 2_12.rmd because I wanted to avoid the dot character. Anything after a dot in a file name will be treated as a file extension. So you really want to make sure that when you save files, you use underscore and you don't use dot. And I'll show you what happens when you use dot. All of the code chunks now get turned into plain text. If I look here, I can see the 212.rmd has a little icon to it next to it. Posit recognizes this as our markdown file and something that it can execute code. All the run tools went away because it's treating 2.12 as an unknown file type. It's treating it like it's a .12 type of file, and I won't be able to run any of the script. So I'm going to delete that file. I could save it by clicking rename, but I have the renamed one here, so I don't have to. But if you're running into that problem, definitely just avoid the dots, and I think you will be fine with any other file names as long as it doesn't have a period in the middle of what you think of as the file name. So good luck finishing up this week with the microbiome project, and let me know if you have any questions.